Hi folks, we're going to take a look at this question here. So they're asking us to solve this equation, and the first thing I'm going to do is look at the left-hand side and make sure you don't get tricked into thinking that you can simplify this with a logarithm law. Okay, because there's nothing that we have to simplify the quotient of two individual logarithms. Okay, and there's no rule for the logarithm of a difference on either numerator and denominator. Okay, so once I realize there really isn't much I can do with the left-hand side, I think what I'm going to do, as we often do when we have a variable in the denominator, is I'm just going to multiply that to the right-hand side of the equation. Okay, so we've got log of 35 minus x cubed equals 3 times log of 5 minus x. Okay, now I've got a logarithm of the same base on either side, which is good, but unfortunately I've got this coefficient of 3 in front, so there's nothing I can do yet to eliminate those logarithms. So the first thing I'm going to do here is bring that 3 up using the ski-slope rule. So we end up with log of 35 minus x cubed equals log of 5 minus x all cubed. Okay, and now I've got something that we can use. So here, two ways you can look at it. You can say, well, you've got two logarithms of the same base on either side, so that means their inputs must be the same. Okay, you can also think of it as taking 10 to the x of both sides, and then we've got inverse functions being applied to this input, so I'm just left with the original input, which is 35 minus x cubed, and here I'd just be left with 5 minus x all cubed. Okay, and so what we managed to do is take this logarithmic equation and turn it into a polynomial one, which is something we've seen very often, perhaps not in this particular format. Okay, so now let's solve this equation here. So here, 5 minus x all cubed, I could do it, I could do it by multiplying 5 minus x 3 times, perfectly fine. What I'm going to do though is use Pascal's triangle to solve this, so it's a good time to review this. So remember that if you've got a plus b to the n, in this case here to the 3, the coefficients are given by, and I'll just draw Pascal's triangle on the side, at least to the third row. Okay, so remember the 0th row, first row, second row, third row. So this is the one I'm going to be using, and these are going to give me my coefficients. And then, of course, I have to take the different powers of a and b. Okay, so let's do that on the right-hand side. So left-hand side, already pretty simple. So here, first it's going to be a cubed, so 5 cubed, which is 125. Okay, then plus. Okay, so now I'm going to take our coefficient of 3. So that first coefficient was just 1 times 5 cubed. Now we're going to have a coefficient of 3. And now we're going to square the 5. Okay, so that's 25. And now we're going to take negative x, because here a plus b, so that means b is equal to negative x, is we're going to take it to the exponent 1. So just negative x. Okay, plus. Now our next coefficient is 3 again. Okay, now I'm going to take 5 to the exponent of 1 and negative x squared. And then lastly, our last coefficient is 1, and now I'm going to cube the b value, which is negative x, so negative x cubed, and now we can simplify this here. Okay, so not a bad idea to review Pascal's triangle. I don't think you'll need it for the upcoming test, but we'll definitely be using it in this course. Okay, so 35 minus x cubed. So here, what do we have? We have 125 plus, so I guess it's going to be minus. So 3 times 25 is 75x. Here we have 15, and here negative x is squared, so it's going to become positive, so plus 15x squared, and here we're just going to end up with minus x cubed. All right, and this actually works out quite nicely because those will just cancel each other out, so I'm left with 0 equals 15x squared minus 75x. And here we've got 125 minus 35, so that's going to be plus 90. These are all divisible by 15, so I'll make my life easier by factoring out the 15. So what do we have here? We've got x squared minus, that's going to be 5x, and this is going to be plus 6. Okay, divide both sides by 15, just get it out of the way. So here we're just left with x minus 2, x minus 3, and so x can equal either 2 or 3. And normally I'd be happy to stop there and say those are my answers, but we have to remember that our original equation was a logarithmic one, and we know that we've got some restrictions on these logarithmic functions. So anything that makes the inputs less than 0 or less than or equal to 0 is a problem, and anything that makes the denominator equal to 0 would also be a problem. So let's just check this out. So let's check out the 3. 35 minus 8, positive, positive, and the denominator is not going to be equal to 0, so 2 is a perfectly good answer. And let's do the same thing with 3. 35 minus 27, positive, this is still positive, doesn't make the denominator 0, so both answers are correct. Okay, so let's just do a quick recap here. Number 1 is to realize that there's no simplification on the left-hand side. Okay, so we do what we normally do, try to bring everything so that we're working with variables only in the numerators. And then from here, I just had to think of using the ski-slope rule in order to get to a place where I could simplify my equation into a polynomial. Okay, that's it for this one.